I am gonna study some quantum too. Wait, what the fuck is happening? Help, help, help.
Welcome to Theoretical Non-Normie Physics. Yeah, that is every undergrad student ever when he start learning quantum mechanics. He or she be like, what the fuck is Hilbert space? What is a ket? She live in Hilbert space too. So what the fuck is it? That operator is her mission. What? Why? Bruh, please. All this question and misunderstanding. And all misconceptions that come out of it, because most of theory of quantum mechanics they give it to us like a postulate. But the theoretical physicist who developed the quantum theory, they had some type of reasoning and logic to develop the theory. So that what we gonna do in this video series. It's a two-part series. First part we do a deep dive in history, and look to experiments that start quantum mechanics, and try to derive all theory and principle and phenomenon of quantum physics. After we set up the theory we start part 2. Part 2 is formalism. Every physics theory need a formalism. Why? For better and easy notation, and an elegant math to make theory easy to work. Like in classical mechanics, from Victorian Newtonian mechanics to scalar Lagrangian or Hamiltonian mechanics, dealing with scalar is better than dealing with vector. So in this first video of part 1 we gonna start with trying to solve the ultraviolet catastrophe and derive Planck energy law. We gonna find it not postulated. All that with help of our theoretical physicist guests of today video. Lord Rayleigh and Sir James Jeans gonna derive the Rayleigh-Jeans law and laugh at their catastrophe. Then me and Planck we gonna try and solve it. But first a word from our Lord who give us the Kelvin unit, William Thomson, 1st Baron.
There is nothing new to be discovered in physics now. All that remains is more and more precise measurement.
Who would win? Put your answer in comment 10. If black box win, hit that like. Before we start we need to find some physics concept about what we gonna derive, matter radiation, and some principle from statistical physics. This video about quantum mechanics, so we not gonna go deep in them. Quantum mechanics start when physicists try to explain spectral energy density of black body. So what is a black? When radiation hit matter, that radiation part of it gonna be absorbed and reflected and transmitted by the body like this equation show. And we gonna divide it by Q to work with coefficient, because physicists like to work like that. So we have a coefficient of absorption and reflection and transmission. For example, if a white light hit an object, and that object is red, that mean the object absorbed all color and reflect red. So a black body absorb all radiation, that mean A equals 1 and R equals T equals 0. So the black body wanna stay in thermal equilibrium, that mean to stay in a constant temperature as all object and physics phenomenon, is to be in lowest state of energy possible. That why thing fall in soap bubble, have a spherical shape. We will learn that about this in future videos. So he gonna emit all those radiation, but some radiation gonna be more brighter. So if we know then temperature we will know the type of radiation, and that mean the wavelength of our radiation with Wien's displacement law. And if it in the visible spectrum, we will see it with our eyes, like when some iron getting heated up, we see the radiation that it. So the black body radiation gives us this graph, and it is an energy density in function of frequency. So Lord Rayleigh and Sir James Jeans gonna try to find this energy density. The energy density is given by this law. This call the average energy. This is the number of particles or mode for wave. Let's talk about the number of particles or mode for wave. Starting with particles, it's simple, it's just the number of particle. So if we have 2 particles and average energy at 100 joule, the energy density is 200 joule. But in wave we have modes, and it is the wave vibration, and it depend on frequency. This call the fundamental mode of vibration. This call the second mode of vibration. This call third mode of vibration. So you get the idea. Every time the number of mode go up, the frequency rise and the energy too. Now we need some concept from statistical mechanics, so we not gonna go deep in them, just a quick look because this video about quantum mechanics and we will see them in future videos. So the average energy is given by this formula. For continuous energy, for discrete energy, P is the probability to find the state of the system in a state of energy E in thermal equilibrium. This is one of the most powerful tools in statistical physics. Can use it to find the probability of finding the system in any particular microstate when the system is in thermal equilibrium. He tell us how the system distribute energy. We see that most of particle of system are in try to be on lowest energy possible. Z is the partition function. Tell us all possible state of system. We derive it from the normalization of probability. Example, our system is an electron, and electron can be spin up or down. So partition function. Let's do a quick example to explain this formula. Let's say we have an atom, and she can be in those three energies. The average energy is the probability to find the atom that energy state multiplying it with the value of that energy state. So let's find a nice formula for the continuous average energy. It's same for discrete average energy. We say when we are in thermal equilibrium, the probability is given by the Boltzmann probability distribution. Z is the partition function, and we the little bit of math massage and putting kt to be beta, and playing with partition function. We get this formula, so we gonna help Lord Rayleigh and Sir James Jeans, and we gonna calculate the average energy for them, and they gonna finish the rest, and that is find the n. So we just need to apply the formula, and we get the average energy and it equal to kt, and it's so logical, and at the definition of temperature. Temperature is just the average energy of particle, and how fast they move and collide. I love to go in more details, but that too much because branch of physics are so depend on each other. Like when or physicist gonna derive their law, they gonna use laws from all branch of physics, but I will put some link in description to better understanding and get back to them in future video. Now Lord Rayleigh and Sir James Jeans gonna derive Rayleigh-Jeans law.
Hey, my name is Lord Rayleigh. I was born November 12, 1842 and I died in 1919 and I have a Nobel Prize in Physics.
Hey, my name is Sir James Jeans. I was born in September 11 and I died in 1946.
Hey, my name is Max Planck and they call me the godfather of quantum physics. I was born in April 23, 1858 in Germany and I died in 1947 and I also have a Nobel Prize in Physics.
We consider the blackbody to be in the shape of a cubical metal cavity of side L with a small hole in it. The electric field must vanish inside a metal, so the electric field in boundary of cavity is zero and it will form a standing wave of the electric field. Standing wave are just sin or cos function, all that because electric field obey the wave equation. So we have standing wave inside the cavity, so we need to calculate the modes of waves n to get the energy density. So when we put the electric field in the wave equation we get the diffusion relation. So we gonna go to n space to find all possible mode that this wave could have. N space is all possible that the three number n can take, and every n forms an axis, and along that axis all possible n that n could take, so we can represent all possible state with big N. And big N is a sphere in space, but just 1/8 of that sphere because all n are positive. And so we have the number of mode big N we multiplying by 2 because light have 2 polarization. So we find the number of modes and it depend of frequency. So now we need to know how this number change when frequency change. Because the graph of the energy density is in function of frequency and we need to count for all frequency and how to the change of frequency affect the energy density. So yeah, we get the energy density, so we graph it and see the result, and I hope it gonna match the experimental result.
What the fuck is this shit?
No, that is bad, is very bad. Ha 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 ha, that's so bad it's away far from the experimental result.
It's a catastrophe, an ultraviolet catastrophe, not even close to the experimental result in higher frequency and low wavelength. So me and Planck we finish laughing, so let's derive the solution to this catastrophe. Now Planck he gonna tell us how he find his law and solve the problem.
So we have the energy density graph and it in the form of this function, and here x is proportional to frequency, and we have that the number of modes is proportional to square of frequency. So the rest of equation is proportional the average energy, so we now the form of the average energy function, so x have the unit of energy and the exponential need to be dimensionless. So we put the beta with x because beta have the unit of inverse of the energy. So now we try to find the partition function, then find the energy that generate this average energy function. With simple integral step we find the partition function. So this is our partition function, and we know the partition function can be write in the form of a sum or an integral. Yo Kito, what series this partition function look like?
I think it look like geometric series.
Yep, you are right Kito, you will be a great theoretical physicist one day like me.
Stop it Max, stop it.
So as he said, it's a geometric series sum. After we write in form of sum, this is the form of the energy, and it a discrete energy, not continuous as Lord Rayleigh and Sir James Jeans assumed. So here we have our energy formula, and it's something new, physicist never saw nothing like this before, and it took me 6 years to come up with a physical explanation. Because it's so weird, and we always work with continuous energy, but this energy it is discrete, and I thought it was wrong first, but it the best thing we find to explain the energy density graph. Then I said fuck it, I am gonna publish my work. So here my explanation: the wall of the cavity made from atoms, and those atoms vibrate, and the speed of vibration, or in other term the frequency of vibration, depend of the energy that atoms have. More energy the more the atoms vibrate, so they like little oscillators, and those little oscillators absorb and emit light radiation. So if an oscillator absorb radiation with certain frequency, it will get excited, then it emit radiation. There nothing new here. We see this in everyday life. We see it in when we heat metal, the metal color change because the radiation that he emit. So in Rayleigh and James derivation, the radiation and oscillator work like this. Oscillators can have any frequency, so oscillators can have high frequency, and most radiation will be in high frequency. So here we go again with the ultraviolet catastrophe. But to avoid the catastrophe, the equation tell us that oscillator can't have any energy they want, the oscillator can have some discrete value of energy, and other energy are forbidden. So the allowed energy are those integer multiple of some small value of energy, the other energy are forbidden, as the equation say we can't have energy like this. So we see our energy come in small discrete quantity, or in chunks, or in quanta in Latin. So now we plug our energy in the Boltzmann probability to see what are the energy that is most likely to our oscillator to have and the less likely to have. So from the probability distribution, we see that our oscillator most likely to have a low to medium energy, rather having high energy. So this explain the energy density graph. We see that big peak in center of the energy density graph because the oscillator most likely to have medium energy. And that drop off of energy density in higher frequency because the oscillator is unlikely to have a high energy. So now we gonna edit this equation little bit, so we know that x proportional to frequency and he have the unit of energy, and the energy only depend of the frequency. So we have x equals to a constant multiplying with the frequency, and that constant I will name it h, and it carrying my name, and those stupid experimental physicists will find his value. Theoretical physics is the best.
So we solved the problem. Ye Planck, you did it.
And that who I find the Planck energy equation, and that why they call me the godfather of quantum mechanics, so that how theoretical physics work. In theoretical physics we do assumption and hypothesis stuff and try to find the right answer, and we gonna talk about how theoretical physicists work. In this series we'll see that when we gonna derive the rest quantum theory.
A big thanks for our all theoretical physics in this video. Here a picture of Professor Cat. I know it was a long video and have a lot of info in it. So next video we'll solve photoelectric effect with Albert Einstein and Louis de Broglie. So thanks for watching. See you in next video. I hope you learned something new today.